We've gone through the ideal gas law, and I do want to do an example of using the ideal gas law. So here we go. Maybe I would like to know how much gas, how many gas particles, how many gas particles are there in 10 cubic meters? Let's define some conditions, so we'll say, let's assume STP. So STP, we are going to have standard temperature and pressure. Our temperature is going to be 273.15 Kelvin, and our pressure is going to be 1.01 times 10 to the 5th pascals. These numbers come straight from being STP. Sure, I'll take that. The other thing that we know is that our Boltzmann constant is going to be 1.38 times 10 to the negative 23rd, and that is joules per Kelvin. So we can plug those in. We're going to say P times V equals N, which is what we're looking for, times Boltzmann constant times T, so our N works out to be PV over KT. I'm going to get 1.01 times 10 to the 5th pascals times a volume of 10 cubic meters. Boltzmann constant and the temperature. Now I'm hoping that this is a big number because it very much should be. 10 cubic meters is a lot of space, so I should be getting a lot of gas particles, but I'll plug these in. And I do get a big number, 2.68 times 10 to the 26th particles. That is a lot. That's a 2, give or take, followed by 26 zeros. So then maybe I'd like to know, how does the pressure change if I condense this thing down to 1 cubic meter? And we will say, we'll let the temperature stay the same. So now I'm looking for the pressure. I'm going to start with ideal gas law again. PV equals NKT. I'm looking for the pressure. So I'm going to get an NKT over V. Now I know, looking at it mathematically, that if nothing else is going to stay the same, and I'm just going to decrease my pressure by a factor of, or my volume by a factor of 10, I'm going to increase my pressure by a factor of 10, but I do want to go through the motions. So let's punch these numbers in and see how those work out. So I've got that, got my Boltzmann constant, joules per Kelvin. I've still got my same temperature. And I'm going to divide now by 1 cubic meter, and what I get is 1.01 times 10 to the 6th pascals, which is what I thought it should be, right? I'm decreasing my volume by a factor of 10. I should be increasing my pressure by a factor of 10. But that's all I'm doing with this. I am using my ideal gas law. The big tricks in this one were recognizing that STP gave me some values, and that kind of comes up quite a bit. It's an easy sort of question to write, and it's an easy way to specify what's going on without spelling out all the details. So you'll probably see that quite a bit, especially if you continue on with physics, or if you are looking at like an MCAT or anything like that, any kind of an admissions test that uses physics, it's really common to see STP used. That's the whole process.